is the video lesson for Algebra 2, 2.1, using linear models. So the objectives here are to write linear models that model real-world data and then to make predictions from those linear models. So the first thing we're going to learn about is something called a scatter plot. This is just a graph that relates two sets of data by plotting the data as ordered pairs. And then once you have the data in a graph, you can use the scatter plot to determine the strength of the relationship, or the word correlation. That means the strength of the relationship between the data sets. So the closer that the data points follow along a line with a positive slope, that means that there's going to be a stronger linear relation in the positive direction and stronger positive correlation between the two variables, right? And then if it falls along a line with a negative slope, then it has a negative correlation, which you can see here. So this is a strong negative correlation, right? These dots are going pretty clearly down a line that's going down from left to right. This is a weak negative correlation, right? They look like they're going down, but it's not obviously a line. Here they're just all over the place, so this is no correlation. This is a weak positive correlation, right? They seem to be going up, but not in a great line. And here, this is much stronger. You can see them going more in a line here. Okay, so for the first problem, it's going to ask us to create a scatter plot and then describe the correlation of that scatter plot. And the data here is for the average temperatures by month and the electricity bill. So we're actually going to be comparing average monthly temperatures and then the electricity costs. So let's make a graph here. These are all positive, so we'll just use the first quadrant. And sometimes making these scatter plots, you have to kind of figure out where you're going to put on the axis. So here, let's put the temperature, and we're going, that's our lowest one is about 58, and our highest one is about 85. So we need to go from about 60 to 90, or 55 to 90, or 50 to 90. Let's do that. So I like to do this little squiggle here. Let's start 50 here. And then maybe if we go 60, 70, 80, 90, 100. So we're going to go by fives. Okay. And then our electricity bills are going to start at 110 and go up to about 250 something. So let's start at 100. And then let's go by maybe 25s here. 125. Okay, no, it worked better with 50s. Okay. And so this is going to be the bill in dollars. Okay, and then you're just going to plot each one of these points. So this is 61, 150. So let's go to about 61 and then 150. Doesn't have to be perfect. And then 58, 139. So 58, 139, something like that. Okay, and then I'm going to go through and do these on pause. But you get the picture. Okay, so here is the scatter plot of all these data points, right? This was my X and this is my Y, and here are all my points. And you can see that this is pretty strong positive correlation, I think, here. So that's how I would describe this, right? Strong positive correlation. It looks it looks similar to this one up here, right? Okay, so here's one for you to try on your own. So make a graph, just like I did in the last one, or a scatter plot of this data. Decide what's going to be on the X and the Y axis, and make sure you make it so that it all fits. And then describe the correlation after you've made this scatter plot. And then you can check back for the solution. Okay, here is a scatter plot that I did. It didn't matter if you put the test score here or numbers of hours online. But here you can see as the number of hours goes up of hours online, then the test score goes down. And actually, you probably should put this on the bottom because this is the independent variable, right? And this is the dependent variable. So this should be on the x-axis. This should be on the y-axis. And then you can see here, it looks like it's going down. So this looks like a strong negative correlation. Okay, so moving on to problem 2, the table shows the median home prices in Florida. What is the equation of a trend line that models a relationship between time and home prices? Use the equation to predict the median home prices in 2020. Okay, so we're going to take this one step further now. what we're going to do with that is we're going to make our scatter plot, just like we did here. But to come up with an equation of a trend line, we're basically going to pick 2 points on our scatter plot that we think most represents the line that we would create here. So let's say maybe for this here, I'd probably pick this point here, and then this point, maybe this point here, this one here. So this was 4.5 comma 57, and this one was 0, 100, right? And if you draw a line between those 2 points, oops, not that one, and the blue one here, that's a trend that kind of represents the trend. Well, no, maybe, see, it doesn't really, actually, the point of this trend line is the equation of a trend line is you come up with it, the 2 points that you pick. So actually, upon further review, I think I would pick this point and this point, right? And that looks like it's kind of through all of them better. So I would pick this one and this 378. Okay, so once you pick your 2 points, then you're going to use your, you know how to write an equation of a line from 2 points, right? With the point slope formula. So we'll do that for this example. I won't do that for that example. I'm just kind of showing you what a trend line is. Okay, so for the first step in this is to make your scatter plot. So I'll push pause and do it so you don't have to watch me do it. Okay, so here's my scatter plot and then the corresponding points. So you can see this shows a strong positive correlation. And then we just want to pick 2 points that maybe show if you connect them, make a good line that represents this. And so I think I would probably pick these 2 green ones, right? And if we connected them, it's probably a pretty good trend line, kind of showing the trend. Actually, the arrow's going that way, right? Okay, so this point is my 1950, and 40,100. And then this point was my 1990 and my 98,500. Okay, so those are my 2 points that I'm going to use. And for the, I guess I'll make them 1990. I'll actually make the point. So I picked these 2 points. And so I'm going to use these 2 points, 1990, 98,500, and then 1950 and 40,100, and make my a line from these 2 points. Okay, so remember with, you can find the slope by subtracting your y's and subtracting your x's. In this case, right, let's make this x1, and this y1, and this x2, and y2. So then we just subtract the 2 y's, and then we subtract the 2 x's. Okay, and then we get, here, let's make this smaller. That's my math on that. So 58,400 divided by 40 is 1460. Okay, so that's how much it actually changes every year. It's the home price is going up. That's my slope, right? Rise over run. And then we just need a point to use point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. And so we can pick any of these points. Let's just pick this one. So y minus 40,100 equals 14,060 times x minus, which one did I pick? Yeah, 1950. And that's our trend line. Okay, this is my equation of a trend line. You can solve it for y if you want, but it doesn't ask for that. This is an equation of a line, so anytime it asks for equation of a line, if it doesn't tell you the form of that line, you can leave it in whatever form you want. And so that's the equation of a trend line. Again, you could pick any 2 points on here that you think makes a better line. So this is not the actual answer here. This is just an answer that I chose. You could have picked these 2 points or these 2 points. So it's really up to you. I just happened to pick those 2 green points, and this is the line that came from that. Okay, and then it's asking you to use this equation to predict the median home price in 2020. So let's just use this equation, and this is basically an x value. So I'm going to plug that in for x. So y minus 40,100 equals 1460, and then my x is my 2020 minus 1950, and then we just solve for y here. So then we can let's actually add this 40,100 on both sides to do this. Oops. Okay, and so My y equals 14,060, 2020 minus 1950 plus 40,100, and you can just do that in the calculator, and you get 14,230, 142,300. Where's this in Florida? I guess in Florida. I don't think that's probably true now. It's probably a lot higher than that. So maybe that's not true, but it's back then. Maybe that's what it was, or that's what they predicted it to be. It's probably gone up a lot more than that. But that's how you do this, and that's the answer to this question. It says use the equation to predict the home price in 2020, and this would be, oops, your answer if you use this line. Okay, so you make your scatter plot, you pick 2 points that you think make a good line that represents where you think the data is going, then you come up with an equation of that line, and then you use that equation to predict in a future time. Okay, one for you to try on your own. So make your scatter plot, and then pick 2 points that make you think a good line, and then use those 2 points to come up with an equation, and then use that equation to predict the median home price in 2030. Okay, press pause, do that on your own, and then check back to see how close we got to each other. Okay, so I cheated a little bit. I used Desmos, which we're going to be using in the next problem anyway, and I just made a table and made a graph of it. So here's my scatter plot. I picked these 2 points here, so I thought because of here I wanted to split these two there. So I picked these 2 points, and then here's the slope of that, and then I picked this point for my equation and plugged that in. So this is my equation. And then I plugged in 2030, and this is the answer. And then I Googled what's the median home price right now, because now that it's 2020, this is 2030. And in California, it is about 520,000. So this is way off. This is not always the best. Linear models don't always predict stuff like home prices, but it's one way to do predictions. This prediction just happened to be wrong. Okay, so moving on. You coming up with your own trend line is one way to do it, but the calculator actually will do it for you. And let's see if I can move all this. So I'm going to move all this up, sorry, so we can move to problem 3. And so I'm going to show you guys how to do it on the calculator. The calculator can use more, it's actually called regression to do this, and they'll come up with the best fit line. And so this problem is another data set. This is the cost of whole milk by year. And then we're going to use Desmos to come up with the equation for the line of best fit. So I'm going to go over to Desmos and put it in a table and record it, and then put the little video in here and then talk it through while I'm doing the video. So I'm going to press pause and go do that, and I'll be right back. Okay, so I brought my video in of how to do this in Desmos. So if you open up Desmos, and I'll push play, I don't think sound will come in. So if you click this plus in the left corner, you do add a table, and then in your X coordinates, your X column, right, you're going to put this 1998, 2000, the year right there. You can see Desmos actually figures out the pattern and then fills it in for you and does it fast for you. And then here you're going to put your cost of whole milk down in your Y column. Okay, so you're putting your table in. Oh, the sound did actually come in. I guess it's just when I save it to YouTube, the sound doesn't come. Okay, and then, I guess I could have been talking while I did it, sorry. Then if you change your picture here, your settings, so that the x-axis shows this, right? I put 1997 to 2009 just so that these are all included. And then the y-axis I did from 2 to 4. Then you can actually see your scatter plot here. And then click away, and there's your scatter plot. So, and then in Desmos, they'll figure out the best line of fit. It's not you just picking 2 points, right? And how you do that is you find the Y button, and then you put a 1, and it'll do a Y1 subscript. Then you have to find this little squiggly line, which is at the bottom of this video. You can probably see it, the little squiggle line. Then you're basically drawing, making Y equals mx plus b, but your Y is your Y1, your X is your X1, and then your equal sign is this little squiggly line here. So let me see if I can move, let me change the hands, see if I can move this video. Okay, and then put it in the corner. Okay, so how you're going to use this now is when you have this in Desmos, The line of best fit is they give you, when you write this, it gives you the parameters. This is your M and your B. So the line of best fit is going to be y equals M, and so your M here is 0.0934. Let's do that. Let's take all those numbers. And then, sorry, that's your M, right? Y equals mx plus b. X, and then b is this minus 184.051. Okay? And so this is asking, what is your line of best fit? This is the line of best fit. And how accurate is your line of best fit? So the accuracy of your line of best fit is going to be this number here, this R. And since this R is really close to 1, that means it's pretty accurate. So the closer it is to 1, the better. This is 0.91, that's pretty close. So I would say it's pretty accurate. So since R is or close-ish to 1, it's pretty accurate. Okay? And then, based on your linear model, how much would a gallon of milk cost in 2020? You're just going to plug in 2020 for X, so Y equals 0.0934 times 2020 minus 184.051. And you can do that on your calculator, and you get about $4.62. And considering it's about 2020 now, I probably pay a little bit less than that for a gallon of milk. But there is definitely gallons of milk that are more than that, so maybe that's pretty accurate. Okay, so now there's one for you to try on your own. So press pause, get out your Desmos. So maybe if you're watching this video while you're on your iPad, you can pull up your Desmos from the bottom and put in your table and put this in your table and change the axes so you can see the line, and then go into your y equals mx plus b, just like the video showed. Okay, and then see if you can find your line of best fit, and then use that line to figure out how much you would pay for a gallon of 2% milk in 2025. And press pause and do that, and then you can check back and see if you got the same thing as me, and then we'll be done. Okay, so if you put it in Desmos and got your line of best fit, you'll see the M is 0.093 and this is the B. So this is your line of best fit. Oops, do you see my mistake here? Not M, this is X, right? And so when X is 2025, you plug that in, you should have got it about $5.06 for a gallon of 2% milk. Okay, that's it. Time for practice. Enjoy.